This is Algebra 2, 1C.4c. We're talking about the best method for solving a quadratic equation. We're looking at factoring at the moment. Typically, factoring is considered our best method. It's the least amount of steps. It's a little arguable, but when you're looking at a problem like this with an a value of 1, we would consider this to be most appropriately factored to solve for it. When we factor it, we're going to use the zero product property to actually figure out the actual zeros. To help you remember how to factor it, what you got to do in your head is a times c. That's negative 18. That adds to be 7. So you're looking for two numbers that multiply to be negative 18 that add to be 7. Because it's a negative 18, we know the two factors have to be different signs. The signs have to be different to multiply to be negative 18. And the larger number is going to have to be positive because your sum is a positive 7. So the larger number is positive. So negative 1 and 18, negative 2 and 9, negative 3 and 6 are different ways that we can multiply to be negative 18. You can either do that in your head, or you can write out your table, just as a help to be an organizer. You notice that this adds to be negative 17, this adds to be 7, this adds to be 3. We're looking for the one that adds to be 7. If you can do that without a table, that's just fine. So, since the a value is 1, we can go right to the parentheses and call it x minus 2 because it's a negative 2 and x plus 9 because it's a positive 9. That still equals 0. So it's factored. Now we can use the zero product property to solve. It's solving the factored form using the zero product property. This one's a little bit different. This one, we look at it and we see the b term is not an even number. So completing the square would not be good. And it has an a value, so you'd have to factor the 4 out of those, and 4 doesn't go into 11, so it would be really a poor choice to use completing the square. Completing the square is not a good choice. It is pretty much in standard form, so quadratic formula would be a good choice to use here. But it's also, we're going to test it at least, we're going to see if it is factorable. Apparently this is factorable. So I understand if someone would choose to use quadratic formula here. If factoring is not your friend, then you might want to just use quadratic formula. But we're going to practice our factoring. And in factoring, you need everything over to the same side of the equal sign. To factor this, just like before, we're going to take our a term times our c term. That gives us negative 12. That adds to be negative 11. If you can do that in your head, then you can determine really quick if this is factorable or not. Can you think of a number that multiplies to be negative 12 that adds to be negative 11? You know the signs have to be different to multiply to be a negative, and the larger number has to be negative to add to be negative 11. So 1 and negative 12, that did it. That's your negative 11. You could also at least think, right? If you're thinking about all your choices, those are your other choices that you could have considered. But you don't even need to think those if you already know what numbers you're going to use. 1 and negative 12 are the correct way to do it. So, if we're going to use factor by grouping, then we take our 1x and our negative 12x, and we put them inside the a term and the c term. That stands for the negative 11. This represents the negative 11 because positive 1 and negative 12 is negative 11. We're going to circle, not put parentheses, but we're going to circle those two groups. That gets your eyes to really look into what you're trying to do. And you factor out your x, and that leaves you 4x plus 1. Bring down your negative. Factor out your 3. That leaves you 4x. This is the tricky part. Negative 3 times what gives us negative 3? Negative 3 times a positive 1 gives us a negative 3. So what I've done out of both of these groups, I have factored out the term that is the same. What's the same in both of these sides of the plus? They both have an x, so I pulled out my x. And 4x plus 1 would be left over. What's the same? What divides into 12? What divides into 3? Simply a 3 does. So I pull that 3 out. That means 12 divided by 3 is 4, and 3 divided by 3 is 1. Now I have it as x minus 3, because those are the values outside the identical parentheses. And then I have the identical parentheses. You don't need to say squared. So there you factored it. You were able to factor it. Now we use the zero product property to solve it. So I set my first factor equal to 0, and I set my second factor equal to 0. And I got my two answers, 3 and negative 1/4. So next we're going to go down and use square roots to solve problems. Let's take a look. Why would square roots be most appropriate in this situation? I'm looking here at this example. It doesn't have a b term. It's not written all multiplied out like these two were written out with an a term, a b term, and a c term. This is not written in that form. You might say that this has an h and a k. It's almost in vertex form. So that would be the most appropriate here, is to use square roots. You could perhaps multiply it out and get it back into standard form, and maybe it's factorable. But if you have to convert it to do something else, that's probably not the best method. So we're going to add 4. To get 75. We're going to divide by 3. To get 25. What would come next? I got to be sure that you're thinking about what we're doing. We have to square root both sides. So we get x plus 2 equals plus or minus the square root of 25. So plus or minus the value of 5. So we have x equals, I'm going to subtract my 2 to the other side. Subtract my 2 to the other side, and I'm going to have a positive 5, or I'm also going to have a negative 5. So I'm going to get two different answers. Looks like I'm going to get 3, or I'm going to get negative 7. What that tells me is I actually could have used factoring if I converted this to standard form. But again, that probably wouldn't have been considered the best choice. If we're trying to pick the best method, that's what this lesson's a little bit about, picking the best method, that would not be a best method. Using square roots would be the best method. Over here, what do we see? This one's a little gray. You got choices here. probably, because it does not have a b term, you do not see a b term. You don't see a number x. You have x squared, so that gives us an a term, but we don't have a b term. So most likely the majority of you would move the 9 across, divide by the 4, and then take the square root. And you would get x equals plus or minus 2. The other way you could consider doing this, instead of moving the 9 across, you could have moved the 25 across and moved the 25 to the left. That would have given us negative 16. And then I would see that this is the difference of two perfect squares. That actually has a GCF. If you're a factoring one, you might actually like this instead. And x equals 2 and x equals negative 2. So really, either method would have been appropriate in that case. You could have used quadratic formula. The b value is 0. The a value is 4. Your c value, you would have had to have used negative 16. But because it was solved using square roots, that's probably your best option. Because it was solved by factoring, you could probably use that definitely before quadratic formula. Here's another one that we're talking about completing the square. Completing the square is most appropriately used to find the center of a circle in those crazy problems we've seen in the past. That's really what completing the square is for. Otherwise, we could either factor it or we could use quadratic formula. We don't have to worry about solving by completing the square. But in some cases, completing the square is not really too bad. If it's not factorable, like you can't factor this one out. If you brought the 14 to the other side, that would have been a negative 14. Nothing multiplies to be negative 14 and adds to be 10. So it's not factorable. That would be your best choice, but that's not an option. Square roots, we can't use square roots in this format. So to complete the square, you take your 10 divided by 2 and square it. That's 5 squared, which is 25. So I'm going to put my 25 next to my b term and keep my 14 on the other side of the equal sign. And remember, whatever you do to one side of the equal sign, you also have to do to the other side of the equal sign. In some cases, we talk about 25 and then a minus 25. But because I'm on opposite sides of the equal sign, that's why it's the same sign of 25. So why did we put the 25 there? So we could write it as a binomial squared. That is a perfect square trinomial. Can be written as a binomial squared. This adds to be 39. I would take the square root of both sides. And I would subtract my 5. 39 is not reducible besides 3 and 13. 3 and 13 don't have other factors, and 3 and 13 are not perfect squares. So 39 is the best you can do. And there's your answer. We solved it by completing the square. That's a pretty quick, relatively painless method of solving it. Maybe it's even faster than quadratic formula. This one over here. Now, to be honest, because it has an a term, completing the square is more of a challenge with this one. So completing the square might not be considered your best choice. I totally agree. We're practicing completing the square, so let's practice it. And the reason we can do it is because if we factor the 4 out of the A term, we can also factor the 4 out of the B term. And then that's why it's okay to use completing the square. So I'm going to practice this time with just moving my -5 off to the side. You could bring it to the opposite side of the equal sign. That would be totally fine. But just so we practice different methods, I'll just push it off to the edge, factor out of my 4 from the A and the B. Now I take my B term, divide it by 2 and square it. I get an answer of 1. So if I put 1 in the parenthesis, what am I going to put next to the -5? It's going to be a -4. Because we put a 1 here, this is really 4 times 1. 4 times 1. So I need to match that, and because I'm on the same side of the equal sign. So the reason we put that in there is so we could factor this apart. Now I like to show you this process, this organization, because this is your vertex form. Now we've actually practiced it doing vertex form. This is your actual equation. It would be a vertex of -1 and -9 for this equation. If we're solving it, we would then move our 9 across. That gives us 4x plus 1 squared equals 9. Divide by the 4. We have 9/4. That gets everyone scared. It's a fraction. I don't know what to do. We haven't done anything yet, so you're just fine. Take the square root of both sides. Gives us x plus 1 equals plus or minus. Now how do I take the square root of 9? 9/4 is to take the square root of the top and take the square root of the bottom. Subtract the 1 across with my fraction. And what I would encourage you to do is to write that fraction with the common denominator. We have the positive 3/2 and we have the negative 3/2.
You get 2 over 2, so why is it 2 over 2?
The value of 1, so 2 over 2 makes 1. It has common denominators with your 3/2. It's going to be negative, so a -2 and a positive 3 makes 1, so 1/2. -2 and -3 make -5, so 5/2. A little bit on the back side, talk about quadratic formula. This type most likely is not factorable. It's possible it could be, but we'll be able to talk about that once we solve it. We're going to practice quadratic formula. If it's not factorable or nicely factored, and completing the square would be kind of tough because it has an a value greater than 1, then quadratic formula seems to be very appropriate. You need to bring all your values to the same side of the equal sign. You need it to equal 0. So your A is 5, your B is -2, and your C is -7. So we're going to put it into our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac 4ac all over 2a. So I'd like you to be sure to write your work to show the numbers that you plugged into the quadratic formula. The quadratic formula, just so we're sure to practice writing it out, is b squared minus 4ac all over 2a. And that's what we did here. We did the opposite of the b. We squared our b, which is squaring negative 2. So we're going to get positive 2. Now, the common mistake is to call that a negative 4. You want to be sure to call that a positive 4 because you're squaring negative 2. This is 20. 20 times 7 is 140, and it's going to be positive. So we get x equals 2 plus or minus 140 plus 4. Hey, wait a minute. Look at this. This is a positive number inside the radical. That means we're going to get two answers. This is just not a positive number. This is called a perfect square. When you have a perfect square, this is a great thing to learn, by the way. You have a perfect square. This was actually factorable. What two things multiply to be negative 35 and add to be negative 2? We could have actually factored this. That would have been negative 7 and positive 5. It's a coincidence, it's those numbers, but that's the way it worked out. So we have x equals 2 plus 12 divided by 10, and x equals 2 minus 12 divided by 10. So this makes 14 divided by 10. So you might divide both of those by 2. And this becomes negative 10 divided by 10, which is negative 1. So we got our two answers. Circle all the equations that used in the quadratic formula would be necessary to use. So here, when we look at it, we multiply here what multiplies to be negative 48 that adds to be 5. That's a kind of a crazy number. 48, you got 6 times 8 is 48. You've got 12 times 4. There's a way to test to see if a standard form is actually factorable, and that is to look at your discriminant. If you look at your discriminant, b squared minus 4ac, 25, two negatives make a positive, 8 times 24, 192, add those together, we get 218, I believe. That would be 17. 217. That is not a perfect square. So this is not factorable. It's not good for completing the square. It's not factorable. So this would be a quadratic formula type question. What multiplies to be negative 8? Well, that would be 4 and 2. This would be the great one to factor. We can test that discriminant thing again. 2 squared minus 4ac. 4 plus, oh, maybe I'm wrong. Oh, no, this adds to be 36, of course, and 36 is a perfect square, so if it's a perfect square, then this is factorable. This is a great way to test if something is factorable. If you're ever trying to factor and you're trying to decide, am I missing something? You can always check the discriminant. If the discriminant is a perfect square, then this is factorable. So if it's factorable, we would not necessarily want to use the quadratic formula. So let's not choose that one. This one here, we would just pull out our x. not even a 5, because 5's not in both of them. It's just the x. So 5x minus 13. And set them both equal to 0. So this would not be a quadratic formula. This one would be a quadratic formula, because you can't multiply to be 7 and add to be 14. You could practice it with the with your discriminant. And then this one, x minus 12 equals 0, that would be appropriate to solve by factoring. This is factoring. It's got the GCF. Set it equal to 0, set it equal to 0, x equals 0, x equals 12. So this is not a quadratic formula type question. This one would be. This one has a GCF. This one's actually factorable. And this one is not factorable. This would be quadratic formula also. There you go.